Good morning, students. Good morning. Yeah, we were talking about periodic classification of elements, right? Yes. So good morning to everyone. So can anyone tell me what we were discussing in the last class? Anyone? So what we were discussing in the last class? Okay, we were talking about atomic size. So before that we were talking about, yes, atomic size. Yes, we were discussing. But before that we were talking about F block elements. Right? So that's what we were talking about, F block elements. So hagadre, when it comes to F block elements, we have two categories. So one is 4F series and another one is 5F series. So what is another name? Another name is inner transition elements. Inner transition elements. F block elements are also called as inner transition elements because n-2 here. General electronic configuration, if you see, F subshell which belongs to n-2 is getting filling up. Therefore, it is called as inner transition. Now, when it comes to D block, it's called as transition, right? But here it is inner transition because there it was n-1 D. But here it is n-2, much more inner, right? That's why it is called as inner transition elements. Okay? So yes, even we were talking about atomic size. I will come to that. Now 4F should belongs to 6th period and 5F belongs to 7th period. 4F belongs to 6th period and 5F belongs to 7th period. Now if I talk about 4F series, it will start from cerium and it will end up at lutetium. So it will start from cerium and it will end up at lutetium. Anyway, you are going to discuss all these things in second P. So it will start from cerium and it will end up at lutetium. Now when it comes to 5F, it will start from thorium and it will end up at lawrencium. It will end up at lawrencium. So that's where we have got the 4F series, 5F series. So total how many elements in 4F series? Naturally it should be 14 elements. Total it should be 14 elements. And here also it should be 14 elements. So total how many F block elements are present? So 28 F block elements are present. Okay? So 4F series, which is called as lanthanoids, which are called as lanthanoids. and 5F series which are called as actinoids. Why they are called as lanthanoids? Because they are present after the lanthanum. Why they are called as actinoids? Because they are present after the actinium. Okay? So, what is that spherical gaming? Yes, good morning to everyone. So, that's where we have the lanthanoids and actinoids. So, why they are called as lanthanoids? Because they start after the lanthanum. So, why they are called as actinoids? Because they start after the actinium. All of you have understood? Any doubts in this? So that's where we have the period number 6 and period number 7. That's where we have 4F series, 5F series. So 4F series starts from cerium ending at lutetium. So 5F series starts from thorium and ends up at lawrencium. So total 14 and 14 elements in each F series. Okay? So why 14 elements? Why not less than that? Why not more than that? So that is because F subshell can accommodate maximum 14 electrons. Okay? So no question of groups because F block elements, they are sandwiched between group 3 and group 4. Okay? So that's why we have the periods. No columns or no groups for F block elements. And now when it comes to actinoids, all of them, they are radioactive elements, and that's where we have transuranium elements. That's where we have the transuranium elements. What do you mean by transuranium elements? So these are the actinoids. These are the actinoids present after the uranium. Present after the uranium. That's where we have the transuranium elements. So what do you mean by transuranium elements? These are the actinoids. It's understood that we are talking about 5F series, or you can just tell that these are the 5F series elements which are present after the uranium. Or you can mention that these are the actinoids which are present after the uranium. Okay? So those elements are called as transuranium elements. Fine? All of you have understood what can be the general electronic configuration for F block elements. So general electronic configuration will be N minus 2. It will be N minus 2 F1 to 40. When it comes to F block elements, the general electronic configuration will be N minus 2 F1 to 40, N minus 1 D, N minus 1 D. What is that? 0 to 1. 0 to 1. And NS2. What is that general electronic configuration? N minus 2 F1 to 14, N minus 1 D 0 to 1, and NS2. So this will be the general electronic configuration for F block elements. All of you have understood? And when it comes to 4F series, it will become 4F 1 to 40. Okay, if I talk about 4F series elements, okay, so now I can mention that 4F 1 to 14, then here it will become 4F series which belongs to 6th period. So naturally it should be 5D 0 to 1, then 6S2, right? Same if I am talking about 5F series, then 5F series, then it will become 5F 1 to 40 and 1 less than this, that is 6D 0 to 1 and 7S2. 7s2. That's where we can write the electronic configuration. All of you have understood? Okay? And please remember, almost all the actinoids are radioactive elements. Almost all the actinoids are radioactive elements. So that's where we have the general electronic configuration for F block elements. All of you have understood? Any doubts in this? Okay. Then we were talking about the atomic size. We were talking about the atomic size. Now when I am talking about atomic size, if you consider the distribution of the elements based on their atomic size, if I consider, now all of us we know that down the group, okay, down the group, what will happen? Atomic size is going to increase. Okay, atomic size is going to increase. That's what? Atomic size will be increasing down the group. So therefore I will mention down the group, atomic size will increase. Atomic size will increase. This is important. Okay, I will mention it as very important. So atomic size will increase. So what is the reason why they have to increase? Okay, so down the group there will be increasing in the atomic size. Yes, big shit. Good morning. Okay, good morning everyone. So therefore down the group atomic size will increase, right? So why they are going to increase? What is the reason? That is because down the group, electrons will be moving to, electrons will be entering to next energy level. Next energy level. So due to that, atomic size will be increasing. Or we can further extend. Down the group, electrons will be entering into next energy level as there is an increasing in the atomic number. Next energy level as there is a increase in the atomic number, right? So that's what it will happen down the group. However, what will happen across the period? This is first part. This will be first part. So what will happen across the period? So now, if I talk about across the period, okay, so if I consider across the period, now I can tell that there is a decrease in the atomic size. There is a decrease in the atomic size. All of you can see that's what it will happen across the period. So now I can tell why there is a decrease in the atomic size across the period. Or first we can make the statement. So first we can make the statement. Across the period, atomic size of the elements will decrease. Across the period, atomic size will decrease. Here what is happening? Down the group, atomic size will increase. Okay? Now, question here is, why there is a decrease in the atomic size across the period? What is the reason? Now you can tell that across the period, electrons will enter into same energy level. Electrons will enter into same energy level as there is a increase in the atomic number. As there is an increase in the atomic number. All of you have understood? Please remember, this is very important, related to atomic size. And if you understand this one, many stories you can explain. Many of the properties of the elements in the periodic table you can explain if you know with respect to the atomic size. Any doubts? So down the group, atomic size will increase because we are moving to the next energy level. Across the period, atomic size will decrease. That is because electrons will be entering into same energy level. So due to that, what will happen? Nuclear force is getting increased because atomic number is getting increased. So there will be contraction of orbital will take place. Okay? Any doubts? Any doubts until here? If you have any doubts, you can tell. Decrease as nuclear charge increases. Okay, fine. Nuclear charge, Rohan, if you write only that much, it will be half answer. Yes, there is an increase in atomic number, naturally increase in nuclear charge, but electrons are present in same energy level. That is important, Rohan. Because down the group also, there is an increasing in the nuclear charge, no doubt. Down the group also, there is an increasing in the nuclear charge, but still atomic size is getting increases, Rohan. Fine? So otherwise, the statement will become incomplete, half complete. So you have to mention electrons are entering into same energy level across the period. So therefore atomic size increases as there is increasing in the atomic number. So when I am telling there is increasing in the atomic number, that means I am telling that there is an increase in the nuclear charge. Because what do you mean by atomic number? Atomic number is nothing but number of protons present in the nucleus. And proton is the only one which is having charge with respect to the nucleus, because another subatomic particle which is present inside the nucleus is neutron. Neutron does not have any charge. So naturally when there is increasing in the atomic number, that indicates that there is increase in the nuclear charge. You can use the word atomic number or you can use the word nuclear charge. No doubt, no problem. In both the ways it will be correct. Okay? Okay. Now, that's where it is related to atomic size. Okay, that's where it is related to atomic size. Now, I will keep very important there only. So, we will move to the next one. Okay? So, that is with respect to ionic radius. That is with respect to ionic radius. First one was atomic size. Atoms are neutral, but ions are not neutral. Ions will have the charge. They can have the positive charge or they can have the negative charge, right? So that's where we can have the ions, either negatively charged, okay, or positively charged. They are not neutral. That's where they differ from the atoms. Ions are not neutral in nature. They will have excess of positivity or they will have excess of negativity. So therefore they will carry the charge with them. But atoms are neutral. Now when I am talking about negatively charged, which are called as anions. And when I am talking about positively charged, those ions are called as cations. So that's where I have the anions and that's where I have the cations. All of you have understood? Now, see for example, I have sodium and I have chlorine. Now they will interact with each other in such a way that sodium is going to donate the electron to chlorine. Since sodium has lost the electron, it will become Na plus. Since chlorine has gained the electron, it will become Cl minus. Right? Sodium, chlorine, both are atoms, no charge. Now when they comes together, sodium is going to donate its one electron to chlorine. So therefore, sodium will become positive and chlorine will become minus 1. Why one positive and one negative charge? Because only one electrons are involved. Okay? So that's where I have the sodium chloride crystal. As a sodium chloride crystal, they are neutral because they have equal amount of Na plus and Cl minus. As a sodium chloride crystal, they are neutral. Why? They have equal number of Na plus and Cl minus. Now, what happens to their atomic number? Here 11. That means we have the 11 protons inside the nucleus. Here it is 17. We have 17 protons inside the nucleus. What is happening here? Whether there is any change with respect to protons? When sodium has donated its one electron, whether atomic number of sodium has changed? Any one of you? When sodium as an atom, it is having atomic number of 11, where 11 protons are present inside the nucleus. Now my question here is, when sodium will become Na plus by donating one electron to chlorine, whether atomic number of sodium will change? Any one of you? Yes or no? You can type. Whether atomic number of sodium will change? It has become 10. Rohan. Okay. Shashank. No. Any other answers? Only two people they have given the answer. Shashank and Rohan. You can just type yes or no. Whether atomic number will change? Okay. Dikshit and many others. Rohan, Dhanush, no. It cannot be changed. Atomic number will not change. Therefore, I told atomic number is the number of protons present inside the nucleus. That's fine. Okay? But in an atom, we can tell that it is also equals to number of electron. Okay? But when it comes to ions, since there is a gaining and losing of the electron, but still atomic number will remain same because number of protons are same. Whether I am talking about sodium or whether I am talking about Na plus, number of protons are same. There are 11 protons still inside the nucleus, even in Na plus. Even in Na plus. Rohan, okay? Done. So that's where we have the 11 protons which will be constant. But here it was 11 electron, but here it is 10 electron. Since 11 and 10, if I add it up, left over will be plus 1. So that's what we are showing it by symbol, that is Na plus. Same logic is applicable here. So 17 protons, 17 electron in a chlorine atom. That's why no charge. Equal amount of positive and negative. But when it comes to chloride, once again proton number is constant. They are having 17 protons inside the nucleus, no doubt. But what happens to the number of electron? From 17 electrons, since it has gained one extra electron, it has become 18 electrons. From 17, it has become 18 electrons. Okay? Since one negative charge is excess, that will be shown by -1. That's where we have the ions. That's where we have the ions. Either it can be positive or it can be negative. Only two types of ions are there. Don't tell that there are three types. Neutral ion. Okay, when it is neutral, no ion. It is atom. So we have only two types of ions. One is anion and another one is cations. Now, Whether all of you have understood whatever I have explained here? All of you have understood whatever I have explained here? Any doubts? Because next I am going for next concept within the same thing. Whether all of you have understood? Sodium plus. Number of protons are same, number of electrons are different. Chloride. Number of protons are same, number of electrons are different. Okay, done. Okay? Now, listen to me carefully. Now, if I compare atomic size of sodium, if I compare with ionic size of the Na plus, which will be greater? Or I can ask, if I take sodium and Na plus, I will tell that Na plus will be of smaller size compared to Na. Whether yes or no. Just type it as yes or no. If I take the atomic size or ionic size of the sodium will be higher compared to Na plus. Whether yes or no. Chidwan is telling no. Chidwan is telling no. All of you will tell no? Okay. Dhanyata, she is telling. Dhanyata or Dhanyata? Anyway. Sorry if pronunciation is not correct. So, Dhanyata, she is telling yes. No. Yes. Many are telling no. Okay. In that case, Shashank and Dhanyata and even Yagnesh, they are absolutely correct. They are absolutely correct. Since equal number of protons and electrons are there, we will imagine this is the atomic size. But since number of electron is getting decreased, now 11 protons are attracting the electrons. Now proton number is dominating. Nuclear charge is dominating. So naturally, size should go on decreasing as there is a losing of electrons will take place. Okay, as there is a losing of electrons will take place, naturally atomic size or ionic size should decrease. If I consider the size of Na with Na plus will be having smaller size. Try to understand this one. What is the reason? I will give the explanation. When an atom will become cations, since nuclear charge, what do you mean by nuclear charge? That means number of protons. Since nuclear charge, number of protons in the nucleus, since nuclear charge dominates the number of electrons, size will decrease. But my point, this is where I can give the justification. When an atom will become cations, since nuclear charge dominates the number of electrons, size will decrease. Okay? So when I have written, when an atom will become cations, that's where I am telling that there is a losing of electrons. Then only an atom will become cations. Once they lose their electron. Whether this one all of you have understood? Any doubts? Whether all of you have understood whatever I have explained now? They are all important even for your competitive exams, not only for board. Whether I am clear? Okay, Desh. Then we will go to another way round. Now you should tell me, with respect to chlorine and chloride, Cl minus is called as chloride. So if I take Cl chlorine and Cl minus chloride, I will tell that atomic size is going to increase. Yes or no? Amrita, Rakesh, Harshita, you people have given yes sir for earlier one, no doubt. Now you should tell. If I take chlorine atom and if I consider with chloride ion, atomic size or size of the element in chloride is greater. All of you will agree? Size of the chloride is greater. Okay, all of you are telling yes. Yes, now you have understood. Okay. Anju, you are telling no. Okay, Yagnesh, for next one, yes. Okay, pa. So, Anju, she is telling no. No, Anju, you are wrong. It should be yes. Because here, number of protons are constant, but number of electrons are getting increased. Number of electrons are getting increased. So, naturally, if I consider this one as the size of the chlorine, naturally sodium is more compared to chlorine. So chlorine is of smaller size. When it will become chloride, it will become higher size. Okay? Now what is the reason? Exactly contrasting to this one. Contrasting to earlier one. So when an atom will become anions. When an atom will become anions, okay? Since electrons are dominating over, since electrons are dominating over nuclear charge. What do you mean by nuclear charge? That is nothing but number of protons present inside the nucleus. So since electrons are dominating over nuclear charge, size of the element will increase. Size of the element will increase. That's what statement I can give. All of you will agree? Any doubts in this? So that's where we have the ionic radius with respect to anions and cations. So as the element will become cationic form, ionic size is going to decrease. As the element will become anionic form, its size is going to increase. Any doubts? All of you have understood? Here, since proton is going to dominate over the electrons, since proton is going to dominate over the electron, so therefore size is going to decrease. That since electron is going to dominate over the protons, so therefore size is going to increase. That way also you can write electron and proton. That way also you can give the answer. Okay? So shall we move to the next one? That's where we have the ionic size. Ionic radius. Normally they will use the word ionic radius. Any doubts in this? Okay? Okay. So in that case, the question in your exam, it can be a competitive exam or any other exam, question can be like this. Arrange the following elements. Only one example I will take. Arrange the following elements with respect to increasing order of their size. Increasing order of their size. Okay? So we have to arrange the element in their increasing order. So which are those elements? So those elements can be F minus, Na plus, magnesium plus 2, then even we can talk about Aluminium plus 3. So these are the elements. You should arrange them in that increasing order of their ionic radius. All are ions. Can you arrange with increasing order? All are stable elements. All are stable ions, no doubt. All are very stable ions. Just arrange them in that increasing order. First, we should arrange them in that increasing order. Have you observed anything? So whatever I have written, they are isoelectronic species. Actual atomic number of fluorine is 9. Sodium is 11. Magnesium is 12. And aluminium is 30. Right? So that means aluminium, magnesium, sodium, fluorine. Yes, absolutely correct. So according to that, fluoride, since it has gained 1 electron, it has 10 electron. Sodium, since it has lost 1 electron, it has 10 electron. Magnesium, since it has lost 2 electrons, it has 10 electron. Since aluminium has lost 3 electrons, so therefore it will be 10 electron. All of them, they are isoelectronic species. All of them, they are having 10 electrons. Okay? No, Vishwas, no, they are not equal. Okay? So therefore, we can tell that fluoride, since number of electron is dominating, it will be greater than that of the, sodium, Na plus, greater than that of the magnesium plus 2, greater than that of the aluminium plus 3. That is because their atomic number is more. As the atomic number increases and number of electron decreases, atomic size is going to decrease. That's where I have arranged in the decreasing order. Since the question is in increasing order, I can write it as aluminium plus 3, which will be smaller than that of the magnesium plus 2, which will be smaller than that of the Na plus, and which will be smaller than that of the fluoride. So this is where we have the increasing order. So whatever earlier I had written, it is with respect to decreasing order. Whatever I have written here, it is with respect to increasing order. All of you have understood? So aluminium plus 3 should come first, magnesium plus 2 come next, then Na plus, then fluoride. Okay? So anyway, these type of problems we are going to solve even while I will be solving the competitive exam questions. But all of you have understood this one, why aluminium will be of smallest size and why fluoride will be of largest size here. That is because fluoride has formed due to the gaining of electron by the fluorine. So there is a domination of electron over the proton number. So therefore, fluoride should be increasing. All of you have understood? Shall we move to the next one? Okay, any doubts in this? Okay. So ಹಾಗಾದ್ರೆ very important, I will keep it there only. Next one is with respect to ionization. Next one is with respect to ionization enthalpy. The symbolic representation can be delta IH, because in thermodynamics, which you are going to discuss, Capital H stands for enthalpy. Enthalpy is nothing but heat. That is nothing but a form of energy. So try to understand enthalpy word. You are going to study in detail in your thermodynamics topic, which you have in your first PU only. Okay. Now, where enthalpy is nothing but heat. That is nothing but energy. So that's where we have the ionization enthalpy. That is delta IH representation, symbolic representation. When I am talking about ionization enthalpy, where I have the general equation, I have a gaseous atom. I am not talking about the molecule. I have a gaseous atom which will get converted into ionic form. So how it's possible? By donating the one electron or by removal of one electron. Okay? So that's where I have the ionization enthalpy which will be involved during the process. So it can be some value, kilocalories per mole, or it can be kilojoules per mole. Anything is fine. Kilocalories per mole or kilojoules per mole. That is nothing but energy, unit for the energy. Okay? So this is the general equation to define the ionization enthalpy. Now I can define what do you mean by ionization enthalpy. Okay? So what do you mean by ionization enthalpy? So that's where I have the definition. This is the amount of energy. This is the amount of energy required to remove the outer electrons, from the gaseous state of the atom, or we can tell that from the atom under its gaseous state. From the ground state atom, in its gaseous state. So that's where we have the ionization enthalpy. What is the unit? Unit is 6 kilocalories per mole or kilojoules per mole. What is the definition? Definition is, this is the amount of energy required to remove the electrons, or to specify outer electrons, or you can simply mention it as valence electron, to remove the valence or outer electron from the ground state atom in its gaseous state. All of you have understood? So that's where we have the ionization enthalpy. Okay? So yes, naturally, say for example, I have once again, I will take the example of magnet, and I have the iron nail. Now this iron nail was attached to the magnet. We will imagine this iron nail is attached to the magnet. Okay, it is attached. Now if I want to take it out, this iron nail from the magnet, what I have to do? I have to apply the energy. Then only I can take it out, the iron nail from the magnet surface. Same logic is applicable. I have the atom. This is where I have the nucleus. And this is where I have the electrons which will be revolving around the nucleus. So this is positively charged. This is negatively charged. So if I want to take it away from the atom, naturally I have to apply the energy, because I am taking negative charge away from the positive charge. So that's where energy is required for this particular process, and that is called as ionization enthalpy. Got my point? And that's where the atom should be under its ground state. It should be under gaseous condition. Then we have to consider the change in enthalpy or amount of energy involved. We can also define, this is the change in enthalpy. This is change in the enthalpy when a electron, valence electron will be removed from the gaseous state of the atom or ground state of the atom in its gaseous condition. Anything is fine. Okay, so change in enthalpy, that is because delta stands for something getting changed. Initially something energy was there, afterwards some energy was there. That's where change in enthalpy, that way also you can explain, or you can simply mention it as amount of energy. And people will call it as ionization enthalpy or ionization energy. Okay, so in some textbook you will find the word as ionization energy, that is also fine, or ionization enthalpy, that is also fine. In both the cases the meaning is same, that is amount of energy required to remove the valence electron from a gaseous ground state of the atom. Okay, so any doubts in the definition? Any doubts? Okay, fine. So hagadre, now the question can be, explain the distribution of elements in the periodic table with respect to its ionization enthalpy. Explain the distribution of elements in the periodic table based on their ionization enthalpy. Okay, that will be the question. Now you should tell. First you should write definition of ionization enthalpy, no doubt. First you should define what you mean by ionization enthalpy. Then you have to apply those things to the periodic table. Okay, now that's where atomic size, if you have understood properly, that's where atomic size will come to your rescue now. Okay, sir. Dikshit, what is that? I am not understanding. Some code word. Okay na? So hagadre, when I am talking about ionization enthalpy, now first you should define. Okay? Okay. But I was having a doubt what you have written. Okay na? So hagadre, when I am talking about ionization enthalpy, so first you should define what you mean by ionization enthalpy. Now, if you have understood the atomic size, easily you can write this one, because ionization enthalpy, no, it's fine. So, ionization enthalpy is related to atomic size. It is related to atomic size. All of you have understood? Okay. Now, I can tell that the relation between ionization enthalpy, IE stands for ionization enthalpy. Ionization enthalpy is inversely proportional to atomic size. Okay, this is nothing but atomic size, inversely proportional to atomic size. So that's where I have the relation between ionization enthalpy and atomic size. That's where we have the relation between ionization enthalpy and atomic size. That is quite natural, because if I have an atom, a large sized atom, now I have the electron, and I have another atom which is small sized atom, and I have the electron. Okay? Naturally, in this case, in first condition and in second condition, in first atom and in the second atom, and in which atom electrons are near to the nucleus? Anyone? Whether in first atom or second atom, where electrons are near to the nucleus? You can just tell one or two. Yes, Chitwan, naturally, all of you can see. In case of the second atom, electron is near to the nucleus. Right? Yes, all of you have written. Yes, all of you are correct. We can easily find it out. This is the nucleus and this is where electron and nucleus distance. This is nucleus, this is where electron and nucleus distance. Now all of us we know, as the electrons are far from the nucleus, as the electrons will be far from the nucleus, they demands less or they will be feeling less nuclear force. Listen to me carefully. As the electrons are far from the nucleus, they will have less nuclear force acting on them. Once again I will repeat, listen to me carefully. As the electrons are far from the nucleus, they will feel less nuclear force acting on them. Who? Electrons. But exactly opposite. As the electrons are near to the nucleus, they will feel more nuclear force acting on them. All of you have understood? As the electrons are close to the nucleus, they will feel more nuclear force acting on them because they are near to the nucleus. Same logic is applicable. Since electron is away from the nucleus, it demands less energy. It demands less energy to remove the electron, to knock out the electron. Okay? It demands less energy to knock out the electron. Okay? Some same way. Here it demands high energy or higher. Here it demands lesser energy. Here it demands higher energy to knock out the electron because they are near to the nucleus. They are near to the nucleus. Yes, Dikshit. Okay? All of you have understood? In atom 1, we can remove the electron. We have to apply the energy, no doubt. But less energy we can apply. But in second atom, we have to apply bit high energy to remove the electron because electrons are near to the nucleus in second atom and electrons are far from the nucleus in first atom. Got my point? So therefore, I can tell that since higher energy is required here, second atom is having higher ionization enthalpy. Okay? And first atom will be having lesser ionization enthalpy. All of you have understood? Any doubts? In second case, since they demand higher energy to remove the electron, so therefore they are having higher ionization enthalpy. And in second case, it will be demanding less energy to remove the electron, therefore they will be having lesser ionization enthalpy. Whether I am clear? All of you have understood? Any doubt in this? Any doubt in this? Okay. So if you have understood this one, now I can tell that now since inversely related, they are inversely related, atomic size and ionization enthalpy, since they are inversely related, now I can tell that with respect to ionization energy, this is down the group. Now I can tell that down the group, ionization enthalpy will increase or decrease? Will increase or decrease? Any one of you? Will increase or decrease down the group? Ionization enthalpy will increase or decrease? Anyone? Ionization enthalpy should increase or decrease down the group? Okay, still Shuchita. and Chidvan. Only two are correct. Okay, okay. Now you people are writing. Okay. No increase, Dikshit. It should decrease because down the group, atomic size is going to increase. Atomic size will increase. So as the atomic size increases, ionization enthalpy will decrease. So ionization enthalpy will decrease. Then why? Question. That is because since there is an increase in atomic size, ionization enthalpy will decrease. Ionization enthalpy will decrease down the group. Okay? So it should decrease. Now can you tell me what happens to the across the period? What will happen across the period? What will happen to the ionization enthalpy across the period? It should increase or decrease? Yeah, now you got the point. It should increase because as there is a decrease in atomic size, now we can tell that across the period, ionization enthalpy will increase. Ionization enthalpy will increase. Now the question is why? As there is a decrease in atomic size, ionization enthalpy will increase. As there is a decrease in atomic size, ionization enthalpy will increase. All of you have understood? Okay, any doubts? I will stop here. Any doubts with respect to ionization enthalpy? They are all very important. Therefore, I told, if you know the atomic size, easily you can explain the whole story. Okay? Fine? So that's what. With respect to ionization enthalpy, I will stop here. So what we have discussed now, with respect to ionization enthalpy down the group, ionization enthalpy is going to decrease because as there is an increase in the atomic size down the group. Across the period, ionization enthalpy will be increasing. Why? Because as there is a decrease in the atomic size. Okay? So that's what we have discussed. These questions can be asked for 2 or 3 marks. Explain the distribution of elements across the periodic table. With respect to that, ionization enthalpy. So that time you should explain. Okay? No, it's fine. It's fine, Dikshit. No problem. It's fine. Okay. Okay then. Take care. Please, tomorrow is a Sunday. You have time. Go through everything. And I think today you have test also, right? So try to attempt the questions in the test and do well. I will expect my students to perform nicely in your exam, today's exam. Okay? Fine? Okay. Okay. Yes, Dikshit. Bye. Okay. Thank you. Thank you. Take care. Okay.